For the first one, we are given that PB is 40%. Then the other one, PA given B prime is how many percent? 0.15. So PA intersect B prime will be PB prime. Right? Then this is PA intersect B is equals to 0.15 PB prime. Correct. So this will just be 0.15. 1 minus 0.4. Key calculator. Okay, 0.09. On the Venn diagram, draw the circle out. This is A, this is B. Where is 0.09? This crescent, right? So this B is 0.4, right? So PA union B is just 0.4. Yep. You don't need A. You don't need A. You just don't use a formula. Not always you need to use a formula. Just draw it up. Just draw it out. Just solve it geometrically. Look at it and then just solve it. So in the last stage of variety game show, okay. So contestants aim to open the treasure chest containing a grand prize. The chest can be opened when its 2 locks are unlocked. 2 locks. Okay. Each lock requires a unique key to be unlocked. The contestant is given up to 3 rounds to select 2 correct keys among the 6 different keys on a tray. How many treasure chests are there? Oh, just 1 treasure chest, right? Oh, they got 2 locks on the treasure chest. Okay, great. This is increased comprehension. So this is a treasure chest. With 2 locks. Okay. Okay, great. So then, select 2 among the 6 keys. For each round, he can only select 1 key, which will be tried on both locks. The selected key on a particular round will be removed from the tray after that round, so that the probability that the contestant will win the grand prize second round is 1/15. Okay. For the first one, to show, you only have 2 correct keys, right? Right? And then you have total of 6 keys. So the probability of winning the second round, winning what? The probability of winning the grand prize in second round, right, is to say that it's the same probability of choosing 2 correct keys from 6. Right, so actually you just need to choose 2 correct keys, right, from the 6. So in other words, is the total way of choosing the keys is 6 choose 6 choose 2, right? Then there's only one way to choose it correctly, which is 2 choose 2 lah. You choose the correct keys, 2 choose 2. It's 2 choose 2. So this will be 2 choose 2 divided by 6 choose 2. Which is 1/15. You can, but this is only 1 mark. So and they ask you to show lah, so you can actually sort of like try and error and see what you get. Sorry? Yeah, you need the 3 for the rest. Yes, you're right. So draw the 3 lah. Yeah, I think draw 3 will be good because the subsequent one you will need it. Make sure the tree diagram is the same as mine. So there are 3 rounds only. So here You only have two events here, correct key and not correct key. So it's very easy to see. See correct, not correct, correct, not correct, correct, not correct, correct. Okay? Oh, if this is correct really, if you have two correct, then you can just don't continue the tree diagram. Because you already got it correct. So the tree diagram will look something like that. Okay? There you go. Oh, quite interesting. So this one here will be 2 out of 6. 1 out of 6. Well, actually, the tree diagram may be quite easy. So 1/5. Then this is yeah. Then this will be 6 keys, right? 2 out of 6. So this will be 4 out of 5. The non-correct keys are 4. Then when you go down, we just diminish by 1. 4, 5. It'll be 1/4 and 3/4. This will be 4/6. This would be correct keys, which is be 2/5, 3/5. Then this will be 2/4. This will be 2/4. 1/4 and 3/4. Okay, great. This is a tree diagram. So the grand prize is 1 and the contestant selects the correct key in the first round. The required probability. First round he won. So this is 1 and this is 1. Only these two, because these are the only two strands which C is won in the first, the correct key in the first round. Okay, so the required probability for the first part is just 2. Okay, means you just need it to be the first round. C plus P, C prime C. So this will be 2/6 times 1/5 plus 2/6 times 4/5 times 1/4. So it's 2/6 divided by 5 plus 2/15. Part 2 is we want to find the contestant selects correct key in the first round given that he wins the grand prize. So part 2 required probability. So this one will be given that win grand prize. This probability is contestant selects the correct key first round. Okay, so what you want is the one on top. Alright, let's say this is A. This is A. Let's say this is event A and event B. So A intersect B. If you select key the first round and intersect, you win the grand prize. This is win grand prize. So grand prize will mean that we just need to include this extra one below, which is this PC prime PC, C prime CC. Okay, that's the only one we need to add. The one above is the same as the first one. A intersect B is just A intersect B is just the one we found just now. TB will be 215 plus. Okay, just add the yellow one. This case here will be okay. 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 Here, the variety game show runs for 5 days a week over a 60 period, 60 weeks. Find for you that the mean number of shows per week for which the grand prize is won in the second round is more than 0.4. Okay. Find the mean number of shows per week for which the grand prize is more than 0.4. Confusing. Now, first of all, there are a lot of things going on over a period of 60 weeks. So this one, when you say mean number, the first thing you must think about is our favorite CLT, average number. Okay. And then the grand prize is won in the second round is more than the second round. Grand prize is won in the second round is probability of this one is 1 over 15, right? Which is given. So label this event here. This event let this event let it be W lah, win second round. So probability of winning second round is 0.44. Okay, so now we want to show that the mean number of shows per week for which the grand prize is won in the second round is more than 0.4. I'm gonna run this, So it's this one here. You have 60 weeks period. Each week you have 5 days a week. The game show. Okay. So essentially, n will be what? 60 times 5, which is 300. You don't care about the weeks or what lah. Essentially, you have 300 game shows. Okay, 300 game shows. Then essentially, right, we are talking about you're talking about the mean number of shows per week. You want to find the probability of mean number of shows per week. Number of shows per week is the second one is more than 0.4. So sorry, I don't need this one because now every one week, right? This is 1 week, right? Let's say week, this is a binomial distribution of 5. Every one is 1 over 15, right? Get it? This is every week, 1 week. So you have 1 week, 2 weeks, 3 weeks, all the way to 60 weeks. This is binomial, Every one day, 1 out of 15, 15. Now this I'm considering the weeks, not the total number of games. Initially, I was considering the total number of games is because I didn't read this question properly. They say probability of the mean number of shows per week. So I'm talking about per week now. Okay, every 1 week. So I want if W every 1 week got 5 shows, and every one show you have one contestant winning in the second round is 1 over 15. What I want is the probability of mean number of shows per week means mean number of shows per week. This will refer to bar W. Mean number per week. Is that okay? Mean number per week. So week 1, basically mean number a week. Mean number of shows per week would then be bar W, which is week 1 plus week W all the way to week 60 over 60. Okay, so this is the mean number. So I take week 1, week 2, week 3. So I want this, the required probability is more than 0.4. Yeah, so from here, since this one is CLT already, so since n equals to 60 is large, okay, by central limit theorem, bar W will just be normal distributed of EW variance W over 60. EW will be, we know EW is just, expected W is 5 times 1 over 15. This is 1/3. Then after that, variance of W, 5 times 1 over 15, 14 over 15. CLT, so this is 14 over 45. So in other words, what we're looking at is bar W bar W is normally distributed of 1/3, 14 over 45, approximately, by CLT. Sorry, this is divided by 60 because it's variance W over 60. I forgot to divide by 60 here. This will give us 0.177. Okay. There you go. Just visualize this. You run for 60 weeks. Every 1 week is binomial. Okay, then the average of this will just be 60 weeks, right? Like I said just now I accidentally, because they want the mean of every week, so I'm looking at W1, W2, W3, all the way to W60. I just average every week's results out. I want every week's result. I don't want this. Okay, just take note of that. So initially I thought of this because I didn't read the question properly. So I want the average of every week. You list week 1, week 2, week 3. Every 1 week is a binomial. Then you can get the mean number using the central limit theorem. Okay.